Well, good afternoon. Today we have our webinar on hazardous material surveys, polychlorinated biphenyls PCB, otherwise known as PCB, in Caulk materials. So with that, just starting out with the hazardous material survey, what these are, basically represent a comprehensive survey completed to identify any potential environmental contaminants associated with the interior of a building most commonly, but also you can look at exterior areas if you do have work going on for landscaping or excavation type activities. Identify if there might be tanks or on-site septic systems or things like that that you don't want to get into without knowing prior to that. And done for building structures. A lot of times you'll see these done for buildings, but you also see them done for bridges, other types of structures. You can do a hazardous material survey for. Typically, we conduct them prior to renovation or demolition projects, but you could also, different facilities may perform them just as a routine order of business, just to know what they have in their facility in case they have maintenance or repair activities coming up. They can go ahead and do those without having to worry about getting, a survey or sampling done piecemeal. So where we conduct these hazardous material surveys, as mentioned before, you pretty much can conduct them on any structure. Certain things you're going to want to look for, such as asbestos contained materials, you would have to do for any type of building, any type of structure because of regulatory requirements. But the other items you might be looking for, some facilities that are a little bit more susceptible to these conditions or have a heightened awareness of assessing these and making sure that they're on track to deal with them would be schools and universities, special attention given to science laboratories. You might have some operations there that could introduce hazardous materials to drains, bench tops, fume hoods, things like that. Hospitals and healthcare facilities, industrial settings, those have a lot of different things depending on what the industry is that you're not going to see in a typical building setting, but a lot higher potential for hazardous type materials in an industrial setting than you would have in residential or commercial. Public works buildings, facilities, commercial retail buildings, but pretty much anywhere, any type of building, any type of structure would be good to have a hazardous material survey before you start demoing or renovating and getting into those materials. Why would we conduct these? First off, environmental considerations. You don't want to end up with spills, accidental releases of hazardous materials to an environment. Those can be costly cleanups. They can create a lot of headaches, and quite frankly, it's illegal. So you want to make sure that you know what you're getting into, and you don't have those accidents later on during the renovation and demolition. Worker exposure, that's a big one. You want to make sure any occupants of a building are safe, but you also want to make sure that the workers that are coming in to work on your building or your client's building is adequately protected, and they know what the risks are, they know where the materials are, they know the materials have been taken care of before they dig into it. You also might have some funding requirements, LEED certification. Certain projects are going to have grants applied to them that are going to be tied to having a hazardous material survey done before they release the funds. LEED certification is also a big one if you want to get credits and make sure you're dealing with your hazardous materials appropriately. So first step in doing that is to do that hazardous material survey, identify the hazards, and then you can put together the plan of action to take care of it. And then disposal requirements. Last thing you want to do is, once you get done with the project, demo things, take it to a facility where it's not allowed to be disposed of at. So proper disposal to prevent fines, regulatory action. You want to make sure you assess those items up front, because if you do it on the back end, you could have some delays, some added project costs that you don't want to really deal with. And at that point, the cat's out of the bag, and it's hard to not deal with at that point and pay the extra money for it. So when we're talking about contaminants that you're going to identify during a hazardous material survey, there's pretty much two general categories we're looking at: those related to exposure and those related to disposal. So what items are going to affect either workers or occupants if they're disturbed? So that would be an exposure potential. And then what's going to you know, pretty much everything, it kind of goes into your disposal because you got to make sure you're disposing of things properly. But, you know, certain things you want to assess up front and determine if there's special disposal requirements. Other things are going to have general standard practice to dispose of them, so you don't have to do much on those. But good to identify them and say, okay, these have to go to this type of facility. So here's just a summary of some of the things you might see on an exposure consideration side. Contaminants such as your asbestos, lead, mold, that's, you know, obvious one, a big one there. You don't want to tear into some walls or ceilings and have an exposure issue with mold. Bird or animal waste. If you have a building that's been abandoned, or some active buildings, they might have these waste products in the building that, you know, could cause disease if you're exposed to them. So you want to make sure you know where that is and you're handling it properly. PCB, metals, volatile organic compounds, semi-volatile organic compounds, things you're going to find in chemical products. And then petroleum products, oils, those could be an exposure issue as well if they're not managed properly. On the disposal side, the main thing you're looking at on disposal is primarily is a waste hazardous or is it non-hazardous? You know, all types of waste need to go to a permitted disposal facility, but certain wastes that are considered hazardous need to go to, you know, the hazardous, the landfills that can't accept that hazardous waste. So, and there's some pretty serious impacts if you dispose of a hazardous waste at a facility that isn't allowed to accept that type of waste. So characterize what you have hazardous and what you can dispose of as non-hazardous is always a good step, a good initial step on the disposal criteria. Secondly, you got to look at the specific disposal facility you're looking at taking waste to. There are certain acceptance criteria that different facilities, what they can accept is based on what their permit allows them to accept. So some facilities, even though they're non-hazardous, you know, even though they accept non-hazardous waste, they don't accept all types of non-hazardous waste. So you got to make sure that you confirm with them up front that, you know, they're able to accept the type of waste you're bringing there. PCB waste, you know, we'll talk a little bit more about that later, but the other items you see here, these are mainly your hazardous waste criteria. You know, if a waste is ignitable at a certain temperature, if it ignites below that certain temperature, it has to go out as hazardous waste. If it's reactive, if it's corrosive, you know, certain levels that it has to meet in order to qualify as a non-hazardous waste. But if you do have reactive or corrosive waste, you have to dispose of that as hazardous. And then toxicity, which is often analyzed through the toxicity characteristic leaching procedure. But if you have a product or material that ends up with a toxicity level, that has to go out as hazardous waste as well. So just an overview of the typical process of what we would do on a hazardous material survey and what is common practice is, you know, first step, you want to look at what you have for existing available drawings, documents, pertinent building documents. Has there been a hazardous material survey or asbestos sampling or any type of sampling done in the past? Just because you're going to want to use that information, not to, for one, you don't want to duplicate sampling. For two, if you have a material that's already been determined to be asbestos-containing material, you can't sample it again. You have to continue to treat it as that asbestos-containing material. You also want to look at people familiar with the building, maintenance staff, buildings and grounds directors. Interview them, see what they have on information for past renovations, past repairs, things like that, just to give you a better idea what you have in the building, what you may have. You know, a big thing is things that might be hidden from view within a wall cavity, below a concrete slab that aren't easy to get to. Sometimes that building staff will be able to tip you off on what that might be, or even those building documents might say, you know, there's a vapor barrier under this slab, and some of the older ones even call it out for asbestos barrier membrane or something. So you get lucky with that, and you know, hey, well, chances are you still have asbestos underneath that slab. And then also initial walkthrough visual survey, just to see what you got, see the areas that are going to be affected either by the renovation. If it's a full demolition, just get an overall view of that building and see the types of materials that you're going to want to document and sample and assess. From that point, you develop your sample analysis plan, you inventory your suspect hazardous materials containing items. We'll go through in another slide, the difference between, what things you might inventory only and what things you might sample. So we'll get into that a little later. But then from there, once you have developed that sample analysis plan, go through, do your sampling event, submit samples for laboratory analysis, and then finally evaluate that data, generate a report that the end user can read, review, and understand what you have at the facility. So once we have that information, that report, how are we going to use that information? What's the purpose of it? What can be done with it? Basically, going back to the worker exposure, you can identify those hazards that might be an exposure hazard and say, okay, these are the things you need to take care of before certain workers get in there, either abate it or remediate it, or if it's a hazard that, is more of a, general contractor plans on doing all the work and he's got a mold issue there, well, he at least has to make sure his workers are going to be aware of that and protected against a mold exposure. Whereas an asbestos exposure, you need a licensed contractor to go and remove that, so they get it out of the way. But it's all tied into that worker exposure. Eliminate hazardous materials prior to construction. That's always the best thing to do. If you can get that out of the way, get them all out of the way, and then anyone can go in there after and do their work without having to worry about them. So that's good to know. Meeting your disposal requirements, and then also cost estimating for projects, knowing and controlling your costs. If you have your hazardous materials survey done up front and you've got good comprehensive information, you can estimate how much it's going to take to remove those materials, dispose of them, and not have as many surprises later on in construction. We all know there's things that pop up during construction that were unforeseen, but the more information you can have up front, obviously the better to keep those costs down. So on the sample inventory, I touched on this a little bit earlier. There are definitely items that you want to sample that just makes things a lot easier to know that you've sampled it, whether it is or isn't a hazard, and you know whether or not you have to pay money to remove it. So your asbestos containing materials, there's established laboratory analysis methods for that. It's always better to really have those sampled and determine if it's asbestos or not. Otherwise, you're assuming it's asbestos and you're paying for cleanup of material that you may not really need to abate as an ACM. Lead-based paint, lead-containing paint. A lot of times, depending on the facility, if it's not really a EPA targeted type facility where you have to deal with lead-based paint, you might just assume paints contain lead and go that route. But a lot of times it is good to know whether or not you have a lead-containing paint in your facility. PCB containing caulks, sealants, other materials, bill of materials with concerns relative to metals or chemical contaminants might be a good idea to sample those. Radon. Especially if you're renovating a building, it's good to know, that's a good time to test for radon if it hasn't been done already. That way you can decide, okay, do I need to do something in the lowest level, the basement level, to attack radon and make sure it's not going to be a continued problem if it does test high. Get that in your renovation plans. It's a lot easier to install that type of system when you are renovating a building or you're constructing a building than it is to install it after the fact. Yeah, it finishes up and now you gotta go tear into the floor, drill into it, cut into it, and install a mitigation system. That's not an ideal scenario. So radon's a good one, maybe check up front as well. And then areas of suspect petroleum chemical contamination. This is more to do with your exterior areas. Do you have some tanks that might have leaked? Is it good to go through and assess those, make sure, when you go to excavate soil, you're not going to hit anything that you weren't aware of beforehand. Then there's some areas that you might sample, you might inventory depending on the situation, stored products. If it's in a container that's labeled and that's the product, there's no sense sampling it, what you got. But if you've got some random drums that you just don't know what you're dealing with, might be a good idea to assess those, sample them, and see exactly what they might be. Equipment with suspect PCB containing oil. A lot of times you evaluate that on age of the equipment, whether it makes sense. If it's really old, it might not make sense to sample. Just assume it's got PCB, especially if it's energized and active, and rather than shutting it down, taking it offline, you might just assume it. But if you have some old equipment that's de-energized, nobody knows what or when it was installed, might be a good idea to go ahead and sample that for PCB, and then you know if you got to treat it differently. Areas impacted by bird or animal waste, a lot of times you're really not going to sample that. You know what you got. You know it's a hazard. You know you should deal with it properly. So really not much sense in sampling it, other than you might sample areas outside of that to see if there's an exposure concern outside in occupied areas. Similar with mold impacted areas, if you're doing a renovation demolition project, if you see it, you know you got it, you know you got to get rid of it. Doesn't make a lot of sense to sample it, but again, if you're going to occupy those areas after the renovation, you might want to consider some sampling afterwards. And then on this category over here, the items that often are inventoried, these items are a lot of times labeled, or you pretty much know what the contaminant of concern is. You don't really need to go ahead and sample it. You can just identify it and know that you have to manage it properly. So your suspect CFC, HCFC containing equipment, anything with refrigerants, air conditioning units, refrigerators, things like that. You can check the labels to see if it's a CFC or HCFC, but a lot of times those refrigerants, if you're disposing of something like that, there's specified criteria to take it to a recovery facility or have someone personally recover that product before it's disposed. Light ballast, whether it's got PCB or even other chemicals such as DHP, a lot of times you can see on the labels whether it's PCB or not. If it's not labeled, and it's older, you're assuming it's PCB anyhow. But you're not, these are small items. You're not going to tear into them to try to get an oil sample and test it. You're just going to dispose of it as if it had, PCB in it. Mercury containing items, most often if something contains mercury, whether, lamps, fluorescent lamps, they have mercury in them. But switches, usually you're going to see that mercury in the switch, and it's mercury, telltale, silver colored fluid. So it's in there, no sense sampling it, you just have to dispose of it properly. And then other components, thermostats, things like that. Again, they're going to have switches on that you're going to see the mercury, and you got mercury there. Storage tanks, petroleum containing equipment, batteries, fire extinguishers, items containing radioactive materials, electronics. These are all standard disposal requirements. You know what hazards you have when you have them, so really no sense going ahead and sampling those. So with that brings us to our first question.
All right, you can continue, Cheyenne.
Okay, so two primary categories for which contaminants are identified during a hazardous materials survey. If you went with exposure and disposal, you would be correct. All right, so moving on into, we kind of went through everything as far as what you do on a hazardous materials survey, what, who, what, where, when, why, and how on that. But just to give some examples of what you typically look for or look at that you might want to pay special attention to during a hazardous materials survey. We'll go through a few slides here on that. Notable billing areas that you'd often see a lot of typical or hazards. Boiler rooms, mechanical and electrical rooms, they have a lot of equipment in there, whether, you know, insulation materials that might be asbestos, paints that might be lead. They have, you know, the pumps, motors, things like that that could have petroleum products or even boilers with mercury-containing switches. So good to note. Take a good long look at what you have in your boiler and mechanical and electrical rooms. Laboratory areas that we discussed before, science laboratories in schools and universities. You know, they're going to be handling possibly different compounds, chemicals that might get on the bench tops, might get into the sink drains, sink traps. So good to look at those. Some of them might have special acid drain lines where your acid type residue and stuff would go through. So those drain lines should be handled separately and disposed of separately than other things in the building. Manufacturing areas, garages, all those areas would be high risk areas for different hazards. Some building systems, equipment, and components. Common things you look at: light systems. Those ballast in your light systems may have the PCB oil. The lamps themselves, mercury lamps, HID, high intensity discharge lamps with mercury, different gases. Those things will have hazardous materials that need to be managed appropriately. Emergency systems, primarily your batteries associated with those. You know, if you're taking those offline, you got batteries to deal with and dispose of. Smoke detectors, as you see this picture down here, there's types of smoke detectors that will have radioactive materials, and you'll often be able to tell if you can disengage that cover. You'll see the radioactive symbol there. So I'll have some small amount of radioactive material, but any amount of radioactive material really requires special handling and disposal. So when these smoke detectors are disconnected to be disposed of, you gotta make sure whether or not you're dealing with something with that radioactive material. Transformers and electrical gear, possibly PCB containing oils and other petroleum products. Air handling, ventilation systems, they might have different components that have hazards to them too. One thing, going back to emergency systems, your emergency exit lights, sometimes they'll have what's in a tube like this, it might be tritium, which is another radioactive material. So if you have like a tritium containing exit light, that's something that you need to dispose of as a radioactive waste and handle that appropriately. Some other items, your thermostats, anything you see like this, you're going to have that mercury containing switch right there in the back. If you took the faceplate off, you can clearly see that right there. And a lot of times you might see a switch pretty much similar to this on boilers or such. They might be a little bit bigger, but you can see right through the glass and see that you have mercury in there. So telltale sign that you have something that you need to dispose of as a hazard. Air conditioning, refrigeration equipment with the CFC or HCFC, drinking fountains, that's going to have a refrigeration component in it. That might have CFCs or HCFCs in it. Elevators, especially if it's a hydraulic type elevator equipment, it's going to have hydraulic oil. If it's an older one, possibly PCB containing oils. And then equipment, machinery, pumps, motors, they're all going to have petroleum products that, some with lesser than others, but they'll have some amount of petroleum product in there that you don't want to deal with. Residues and spills, sink traps, especially in your laboratory type areas, you might get some accumulation of different products right there in that sink trap area. Say you had a thermometer spill, common practice and in the past might have been to just go take it over the sink, wash it down. Well, that mercury likes to sit right down in there in that sink trap. So that's sometimes a good area to check into. Fume hoods, bench tops, floor drains, especially if you're in a garage area or type of area here that might deal with automotive repairs, things like that. You're gonna get oils and such washing down into those drain systems. So you might have some concrete that needs some cleaning prior to disposal, or you might have some sludge that you have to dig out and dispose of. Miscellaneous, so things that might not specifically associate with a building system and may or may not be of concern to you know, when you're doing a renovation project. If it's okay, the owner's going to keep track of this stuff, that they're going to move it out and move it back in, we don't have to worry about it. But if it's a full demolition type project, a lot of times these things will have to be dealt with during that demo. So if you have some miscellaneous stored chemicals or petroleum products, those things would have to be dealt with. Compressed gas cylinders, appliances, electronics. New York State has an e-waste law, as well as many other states. So you can't just take your electronic waste out with the normal trash. You got to make sure that that's being recycled appropriately. Then some less common items, sewage. We have facilities where they may have had sewage backup in the past historically that never was really appropriately addressed. Crawl space area might be affected, so maybe there's some things there that should be taken care of before people go down and do work in that area. Biohazards, drugs or pharmaceuticals. You hear of the meth labs, things like that. Those require extensive cleanups before they can reuse the building or even demo it. So those are a possibility out there in different residential settings or other buildings. Paint booths might have some contaminants, residual contaminants in those types of facilities. Media blasting waste, so if you're doing sandblasting or other type of media, that waste may not necessarily be the sand itself, but what did the sand remove might have some chemicals or contaminants in it that would need to be disposed of. And then dust could be a hazard, especially some industrial settings where you got explosivity hazard with dust. So if you have a lot of dust accumulate in a facility, that might be something that you want to take on immediately and get that out of there, so you don't have that explosivity hazard. This slide kind of shows a lot of some different items that might have asbestos contained materials or possibly even PCB in the caulk or paint. So some different things you might be aware of: caulks, pipe wrap, insulation, wallboard, joint compound, plaster, floor tile, ceiling tile, insulations, adhesives, paint. Those are all common suspect asbestos contained materials. But something, again, the regulations really require you to assess these asbestos contained materials before you do any renovations or demolition or repairs. So at the very minimum, when you're doing a hazardous material survey, you would want to look into that ACM. All right, so now we have question 2.
All right, Cheyenne, you can continue.
Okay, so question 2 is, what area of a school or university should be given special attention when considering or performing a hazardous material survey? If you picked C, science laboratories, you would be correct. All right, so now moving on to the outside. Sometimes, like I said, you might be doing some exterior work, excavation work, building additions, new drainage, parking lots, things like that. What might you have on that exterior? So a big one is underground storage tanks. If you have an old underground storage tank that may or may not be active, you may have an issue with potential contamination from that petroleum product that might have been stored there. And that tends to be a costly cleanup if you do discover it, one that you may not have been anticipating. So always good to be aware if there's an underground storage tank before you start digging around the property. Above ground storage tanks, a little bit less risk with those because obviously you can see those. You can see if there's been issues with them. And a lot of times if there was a leak or something or an overfill with those, it's usually addressed at the time of the leak or the overfill, and you don't really have as much of a concern. Or you know, you see the system's failing before it actually fails and you replace it. So those above ground storage things, not a high risk, but good to know if there is anything around the area, especially if they're not in secondary containment or on a concrete pad where they're directly exposed to the ground. You might have some issues there. Historical spill areas, disposal systems, transformers, if you have some exterior transformers. Treated lumber, wood products is another item. Railroad ties, you know, playground equipment. So if you have some old wood playground equipment, you know, wood is not meant to last well in the processed wood anyway, is not meant to last well in the exterior environment. So a lot of times it's going to be treated. So those treatment chemicals can present a hazard. Railroad ties last forever, but there's a reason they last forever. So if you have railroad ties buried in your property, chances are there might be some soil that should be dug up and disposed with those ties. And then playground equipment, you know, you might have, you know, the chromium, copper, arsenic type preservative. So if there's been rain, runoff, things like that, that may have impacted their property as well. So it might be something to look into. Dry wells, basically a hole in the ground where they fill it with gravel or some other media and they discharge drains to it. So if, you know, and a lot of times those are not allowed anymore, depending on the drainage situation. So like floor drains going into a dry well isn't something that's allowed anymore. And oftentimes would be a receptor of contaminant. So you want to make sure you don't have any of those and dig them up and close them out if you do. Septic systems, ash, incineration byproducts, you know, the hazards that might be associated with burying partially combusted materials, you know, that could present some contamination issues. And solid wastes, you know, solid wastes are regulated to be disposed at a permitted disposal facility. So if you're running your own landfill, that's not permitted by having solid waste all over the property. That's not a legal process. So I want to make sure you dispose of all that. You also might have asbestos containing materials on your exterior. So just be aware of that. Stucco siding type materials, transite type siding, very high potential that type of material would have asbestos. Roofing materials are commonly have asbestos, the tars and such, and then caulk materials as well. And then also your lead tan paints might be on the exterior of a house or a building. So just to give a rundown, after we get the information on a hazardous materials survey, most of the time, if your materials are or your building system components are serviceable and are functioning to their intended function, and there's no damage and things like that, you know, a hazardous materials survey identifying those items doesn't mean you have to go ahead and take them out or dispose of them or remove them. But there are certain things that if you do find them in a hazardous materials survey really should be promptly addressed, whether it is to meet regulatory criteria or to prevent further exposure potential risks. And with this, I just to present a list of some of the things that you'd want to address promptly from a hazardous materials survey is anything, if you have building materials determined to contain PCB at greater than 50 part per million, pursuant to the EPA regulations, any building material that meets that condition is considered an unauthorized use, and technically it needs to come out and be disposed of. Asbestos containing materials that are in a damaged condition, often referred to as incidental disturbance type condition, you know, those present a high risk exposure hazard to occupants, workers, whoever may come in contact with them. So those need to be addressed as soon as possible. Equipment or components that are leaking a hazardous material. So if you have those light ballasts that are leaking oil, PCB oil, or a broken mercury switch, obviously you want to get those removed, disposed of, and cleaned up. Waste materials not in the process of being coordinated for disposal. Again, you can't have solid waste just strewn all over your property. That's not a permitted activity. Petroleum storage at capacity is subject to petroleum bulk storage regulations, if not already registered. So if above a certain capacity, 1,100 gallons, your tanks and all that need to be registered. So if there isn't a current registration, you want to make sure that they become registered. Closure of those dry wells, inactive tanks, mold, animal waste, sewage that could be affecting occupants. You really should address those promptly. If you have flaking or deteriorated lead-based paint, that's an exposure concern, so that should be taken care of. And then just some other ones: stored chemicals, petroleum products, not secure locations, regulated hazardous waste, not being managed or properly stored per regulations, dust that may have the explosivity hazard, and then industrial manufacturing systems that may require permits. So those types of items you might get from a hazardous material survey that the owner is going to want to jump on and take care of as soon as they can. All right, so that wraps up what I have for the hazardous material survey, and our last section on the presentation is PCB and Caulk materials. So just to give you a little bit of a chemistry background on the PCB, what these are, they're an aromatic compound. With that, they have the rings here, as you can see, and the PCB a PCB molecule consists of 2 of these rings, and on each of these rings you're going to have your carbon atoms. Here you have 6 carbon atoms on each one of them, and then oftentimes like a benzene ring, you'll see the hydrogen atoms connected to the carbon. What makes it a PCB is some or all of these, or a number of these hydrogen atoms are going to be replaced by chlorine atoms. So that's why polychlorinated biphenyls. And this being an example congener, as you can see, the name of the congener is often attributed where that chlorine atom is. So it's located, there's that one, and that one. So that's where you get the chemical name of the congener. There are 209 various PCB congeners, and these have between 1 and 10 chlorine atoms. And then again, that name depends on where the chlorine atoms are located. What you might see with PCB are what's referred to as R-chlors, and those are actually a trade name that was PCB that were manufactured between 1930 and 1979. It's pretty much the most common PCBs that were manufactured. So when you see PCBs, you often see these R-chlors. And what these are, other than the 1016, which is an anomaly there, but these other ones, those last 2 digits on there represent the percentage by way of your chlorine. So this would have 60%, 21%, 48%, so on. And when you see a laboratory analysis report, a lot of times you'll see them reported under the R-chlors. There were other different types of PCB created that weren't really R-chlors, but when they do an analysis, most of the time that analysis is going to shake out that you're in a certain range that shows, okay, yeah, we have PCB and it's 1248 or it's 1254. So that's what you often see on your laboratory analysis reports. Used as fire retardant insulators, good product for that. So that was the benefit of them. They were banned by the US EPA in 1979. So there may have been some products similar to asbestos when they stopped making certain materials with asbestos, but there may have been some products on shelves, still in stores that were being sold. So it might be 1983 and you're still using this material. I mean, nowadays we're not really using those materials. Those have been cycled out, but obviously there's still some overlap after that ban that those materials probably were still being put in place. Where are PCBs? Well, here's a long list of different materials where they've determined PCBs have been, and I'm sure there's a longer list where they are that we just haven't determined yet. And you might see some things that might jump out and surprise you, but inks, newsprints, fruit wraps, wallpaper, carbonless paper, things like that, Xerox toner. You know, we often hear about the caulk materials, and that is a big one. That's become commonplace to sample for that, but there's other building materials that may have PCBs, maybe less common than caulk, but could have the potential for it. So adhesives, different things like that. So you may want to look at sampling those other materials as well. But you know, as you can see, PCB they definitely will put in a lot of things. And why are they a problem? Well, first off, they're toxic. They're a probable human carcinogen. They also bioaccumulate. So, you know, once it gets introduced into a food chain, it's going to travel up that food chain, fish to, you know, the mammal population. You know, so that's definitely a bad thing. And then very difficult to destroy, which makes it even tougher to deal with because you can't really dechlorinate it easily. You know, there are certain facilities that use real high temperatures and stuff to break them down and process them on a disposal side. But, you know, in your normal environment, normal practices that the general population has access to, they're not going to break them down. They're not going to destroy them. Regulation of PCBs, the EPA, DEC, those are the ones, big players in the regulation. The PCB Mega Rule 40 CFR Part 761, that covers a lot of what you're going to deal with on the PCB side. And in on the New York State side, the DEC does regulate disposal of PCB in New York State as hazardous waste. So anything above that 50 part per million is a regulated hazardous waste here in New York State. Some things to note on the regulatory side, when they wrote this Mega Rule, PCB Mega Rule, it was originally intended for soil, liquids, and paint contaminated with PCB, not intended specifically to deal with the caulk materials or other building materials. So it's hard to, some things don't relay too well. So at times you seem like you're fitting that square peg into a round hole, but it's what we have to work with and what we currently have. So we have to deal with that. They have prepared, the EPA has prepared guidelines for PCB and caulk and other building materials. So those are useful for some clarifications on the regulations, how they apply the regulations to those building materials. And also important to note, there's no current requirement to test any building materials for PCB. So the problem becomes is when you do test them, be aware that you have to address them. If they're above 50 part per million, they have to be addressed. So you have to be aware when you do test that you're able to and willing to take care of it if it is above that 50 part per million threshold. So yeah, again, if you're aware of PCB and caulk in building that exceed that regulatory levels, that's not allowed. Deemed unauthorized use must be remediated and removed. All right, so that brings us to question number 3.
Cheyenne, you can continue.
Okay, so what makes PCB so bad? The answer there is D, all of the above. All right, so some more regulatory information. I mentioned earlier, greater than or equal to 50 part per million PCB is regulated as hazardous material here in New York State. Important to know is different materials have different cleanup and confirmatory sampling requirements under that PCB Mega Rule. So it depends on what you're dealing with and on how you address the cleanup. And PCB remediation in New York State may also be subject to, if it's also in asbestos materials, you got that 12 NYCR Part 56, Code Rule 56, NESHAPs, OSHA type worker exposure protection or ACM school. So that mainly, if you have a combination PCB caulk and asbestos containing caulk material, you have the dual regulations that apply. New York State Education Department, they have a memo that was issued in June 2007 related to PCB and caulk. So they have some information there for any school buildings constructed or renovated between 1950 and 1977, undergoing current renovation or demolition. It's recommended that those be evaluated prior to the renovation for that PCB and the caulk material. So there are some certain agencies and such that are going to require, those assessments every time. So good to be aware of their criteria. So some characteristics of PCB and caulk. First off is they're considerably non-homogeneous. The old practices were to mix two. You'd have two buckets on site, separate buckets, one with the PCB containing, compound oil type compound, and then the other with the caulk. You mix it, you apply it, makes it a little more pliable. So you could have some differences, even in the same caulk material on concentrations, depending on where you sample it from. Very durable. Often when you look at the old material that has PCB in it, it's still pliable, still in good condition. Sometimes, very often, it's outperforming the newer stuff. So it was definitely a good product to use for durability. Fortunately, it had some bad stuff in it. There's no special odor, color, or other obvious indicators of PCB. So that makes it a little difficult when you're doing a cleanup project, especially like your soil material that might be contaminated. You really don't know where to end until you sample. You remove some soil, you sample. If you're high, you remove more soil. You really can't see it in those scenarios. So that makes it tough and no real odor on it. It can exceed concentrations of 10,000 part per million or 1% by weight. So you can have a lot of PCB in a sample. We've definitely had some high ones in hundreds of thousands range. So definitely can have some high concentration PCBs to deal with. There's just a few pictures of where you might see your caulk materials, sidewalks, expansion joints, windows, doors, pretty much anywhere where you have caulk materials, if it's an older material. All right, so there's question number 4.
And you can continue.
Okay, so question 4, at what PCB concentration is material regulated for removal and disposal? The answer there is D, anything greater than or equal to 50 part per million or 50 milligrams per kilogram. All right, so looking at PCB containing bill of materials, a process, a typical process you might follow would be, first of all, identify the PCB containing material. Then you want to look at maybe a risk assessment analysis. Are there other materials that were impacted that you might want to sample and address at the same time? And then go into, okay, if your planned work does not include the complete removal of PCB containing material, then you do have some other options. So 40 CFR 761, they allow for three main options to remediate your PCB containing material. That first one being the performance-based disposal. And that basically says if you follow all the requirements of 40 CFR Part 61 to take care of your material and address your material, then go ahead and do it. You don't have to notify EPA. You don't have to, submit a work plan, anything like that. Just follow the regulation. If there's some things you want to possibly leave things in place and encapsulate or not do the full-on removal that's required by that 40 CFR 761, there is the option to do either a risk-based cleanup and disposal or self-implementing cleanup and disposal. But both of those are going to require you to submit a work plan to the EPA and get their approval and sign off before you do it. So they want to know where it's at, what it is, what you're going to do to monitor it, all that good stuff. So once you get the work plan in place, or you're doing the performance-based cleanup disposal, then you're going to do the remediation and removal of the material, confirmatory sampling analysis. Sometimes that's, if we're just dealing with the caulk material itself and you haven't sampled other materials and you don't know that there's any PCB issues on others, so we're just dealing with the caulk, sometimes it's a visual confirmation there. If you have some soil that might be affected, there's going to be a lot of times the confirmation sample analysis of that. If you're removing concrete material, you may also have confirmation sampling there as well, concrete or brick or something like that. And then you get your remedial action report, documentation of your project completion. So even, you're doing your performance-based, you should have a remedial action report. Doesn't need to be submitted to the EPA, but you should have one on record. If you're doing those other two options, either risk-based or the self-implement and cleanup, you're definitely going to need a remedial action report because that's going to have to be submitted to the EPA for their records. And then a lot of times with those two options, you're going to have some long-term monitoring, long-term sampling, whether it's air, surface, wipe samples, bulk samples, visuals. So you're going to have to continue that on until it's fully removed, basically. And then, on a construction renovation type project, you just progress through the completion of that. So when you get into the sampling for PCB caulk, whether it's part of a limited hazardous materials survey or directed sampling on that caulk, first off, similar to anything else, you want to have any homogeneous materials. Now, I mentioned earlier that these are relatively non-homogeneous with the mixing of the materials, but chances are, if they did that process, you're going to have PCB in the caulk material very much likely above that 50 part per million threshold. You might get a sample that's 100, you might get a sample that's 1,000, on the same material, but really it's the same material. It's got PCB in it. So once you're above that 50, it doesn't really matter what your concentration is. It's above 50. So identify those. Are you sampling adjacent materials? Whether or not you decide to do that, identify the process there, and then assess the exposure and likelihood of migration if you're pursuing a full-on mitigation of the area. Different types of samples, bulk sample, any of your building materials, your soil, concrete, brick, just basically collecting a sample of that material, send it in for analysis, direct analysis on that sample. You can also have wipe samples, surface wipes, sometimes with like a transformer. You'll have to do like some surface wipes to certify it's been cleaned, if that's the case. Also, floors, things like that, that might be adjacent to caulk materials. You could do wipe samples on. And then liquid samples, whether it's oil or if you're doing surface or groundwater type sampling. Most generally, when you're dealing with samples, the EPA likes to see these bulk samples. Wipe samples has some obvious inherent issues with doing that, whereas a bulk sample is pretty well consistent. Take the material, send it to the lab, and they analyze it. So there's not a lot of variation in what's done to do the bulk sampling. So there's just a few photos of some sampling. That's a wipe sample, just standard size template. Go through and grab a wipe sample, and then there's some jarred up samples there. When you do the remediation, first off, you want to have a qualified, experienced remediation contractor. That's always a benefit. These are run-of-the-mill type removal cleanup projects, so you want to make sure that they know what they're doing. A lot of times you'll see your asbestos abatement contractors will also do the PCB containment material removal, which makes sense. It might also be an asbestos containment material, so obviously they'll have to be licensed to do that. But also, they're familiar with the processes, they're familiar with decontamination procedures, work area setup procedures, containment and all that. So they go hand in hand a lot of times. Also should be an OSHA 40-hour HAZWOPER certified personnel. So they do have a background of dealing with hazardous materials. And since anything above 50 part per million is considered hazardous waste in New York State, technically, it is a hazardous waste operation to remove those. So some options other than removal. Again, you can go back to doing your self-implementing cleanup or your risk-based cleanup. Have the EPA sign off on that. You could look at doing an encapsulation. And oftentimes with that, you've got a 3-layer coating, and those 3 layers are alternating colors, so you know if you have breakthrough from one to the other. So if that surface coat is gray and you're seeing red, which is the coat below it, you have a breakthrough of that top layer, and that has to be repaired. So allows you to do a little more effective on your visual to make sure those are still in place. The in-place management option, application at various concentrations, various materials, things like that. So decontamination, so solvent washing on different surfaces might be acceptable. Just one thing to note here on disposal side of things, PCB remediation waste versus bulk product waste. There are different criteria for those, depending on the type of waste you have. The EPA did issue a clarification or a letter out there that allows for building materials to be expanded into the PCB bulk product waste, which allows for easier disposal. It's not easy to dispose of it to begin with, but easier disposal on those types of waste as a bulk product rather than a remediation waste. So not going to get into the fine details of that, but you know, there has been some progress towards allowing a little bit more leeway on building materials than the standard 40 CFR 761 requirements. There's some more information on bulk product waste. I'm not going to go too much into that. All right, so that brings us to question number 5.
Cheyenne, you can continue.
All right, so per 40 CFR part 761, which option does not require notification to the EPA? And that answer is C, the performance-based disposal option does not require